Now look at the second property. If the line PQ is parallel to the x-axis, then the ordinates of P and Q will be equal. And the length PQ is x2 minus x1. That's my x-axis, y-axis, and I have a point P here whose name is x1 comma y1. What do we mean by the point P x1 comma y1? If I drop a perpendicular, say A, to both the axes, to y it is B, then I know that this is x1 and this height is y1. For a few minutes again, forget about the existence of P point. I now have a fresh point Q whose name is x2 comma y2. P is not there on the board. So again from I drop a perpendicular to x-axis, C, and from Q I'll drop a perpendicular to y-axis, that's B again. So this height is y2 and the total length is x2. Now I was given a condition is parallel to x-axis. That means this portion is parallel to x-axis. When these two lines are parallel, the distance between them, what are the two distances which are equal? PA distance and QC distance should be equal because the two lines are parallel. What is PA? Height y1. What is QC? That is the height y2. That means y1 and y2 should be equal. That's my first statement. The ordinates will be equal if the line is parallel to x-axis. Whereas if you look at the same statement above, parallel axis, opposite one, axes are equal. Y-axis parallel, x coordinates are equal. Now the second property says x parallel, opposite, y coordinates equal. Again coming to the second property, I need PQ length. Look at the diagram. PQ length from here to here is same as BQ minus PB. Agree? What is the total length from Q to B? That is x2 minus the distance from P to B, that is x1. Again talking about, that's my second property. Now why I used this modulus symbol specifically? Why didn't I leave it with x2 minus x1? Because I know that distance cannot be negative. So whether it is 3 minus 5 or 5 minus 3, the length should always remain positive. To just say that, we use the modulus symbol. Alifia, is this clear now?
It's clear, sir.
Write down the second property. Are now confusion gone now?
Yes, sir.
Right. Second property diagram, both. Bhumika completed writing?
Yes, sir.
Sahas, can I move ahead? No, okay. So far I have seen two cases. When the line is parallel to x-axis, distance between the 2 points is y2 minus y1, that is difference of y coordinates. Then another case we have seen, if the line is parallel to y-axis, the distance between the points is difference of x coordinates. So if a line is parallel to either x or y, I know how to find the distance between them. But will every line in the plane be parallel to either x-axis or y-axis only? It can be different. Like I have coordinate system, origin. There are 2 points now. A is x1, y1, B is y2. Can everybody see the board now?
Yes, sir.
A is x1, y1, B is x2, y2. I join the 2 points AB. I got a line. Is that line parallel to x-axis or no?
No, sir.
Is the line parallel to y-axis by any chance?
No, sir.
That means can the distance be y2 minus y1?
Yes, sir.
Why? You only said the line is not parallel to x-axis.
Yes, sir.
So will the distance be simply y2 minus y1?
No, sir.
Okay. Then if it is not y2 minus y1, then I think the distance should be x2 minus x1. Will
No,
the
sir.
distance be x2 minus x1?
No, sir.
Why no?
Sir, because it is not even parallel to y-axis.
Then how do I find the distance between the two lines, 2 points now? What is there,
Sir,
sir?
I
We take a
can.
scale.
Sir, we can draw two perpendicular lines from point x1, y1 and x2, y2.
1 minute. I said I have to do it, right? Yeah, I have drawn from x1, y1 and x2, y2. I have drawn. I am actually waiting for Alifia to connect. Yeah, are you back, Alifia?
Yeah, I'm back.
By any chance, are you from Hyderabad?
Yeah, I'm from Hyderabad, but I'm not living in Hyderabad right now.
Okay, as of now, you are not in Hyderabad
Yes, sir.
because the weather conditions are similar in Hyderabad that there is a complete disturbance in net connectivity, and you are also facing the same problem. That's why I asked you. Okay.
No, the problem is that there's like a toggle on the side of the website, right? So whenever I'm
Yeah.
going there, I have like a habit of pressing the back button instead of the cancellation button. So whenever I press the back button, it goes straight to the login page again.
Yeah. Yes. So actually, we wanted to find the distance AB. So Arnav has suggested us to drop perpendiculars. Arnav, what should we do next? Arnav. Oh, he has a problem. No, Arnav, you are not audible. By taking area of the figure, what do you get? How will it give you the length AB length?
I guess that's the correct method to finding out the length, but then I also don't know how to find the length using that method.
Okay. You both are trying to find the area and then half into base into height, right? Okay. I'll suggest a more easier method and which is straightforward. As let's draw perpendiculars from both A to x-axis and y-axis. To B also, we'll draw perpendiculars from x-axis to y-axis. Okay. I marked down all the perpendiculars. L, M, E, Q, blah, blah, blah. So can you tell me what will be OL length? Should be x1. This is also x1. This height is y1. This height is y2. This length is x1. Agreed? This is just naming of the point only, nothing new in this what I wrote. Now observe carefully what I am doing. I drop the perpendicular from that A point on this line BM, which is some point C. Minute, I will log in. Yeah. Is the screen visible to all now again?
Yes.
Yeah. Type of a triangle is ABC. C is this perpendicular. Maybe to just keep the diagram, I'll remove this Y2 and mark it a little lower. Yeah. What type of a triangle is ABC here? Clearly a right angle triangle because I dropped the perpendicular from A onto the line BM. In the right angle triangle, just these two calculations, if you understand, next line is your answer. What is the base AC length? Is it equal to LM length? AC length, this should be same as LM length. Now that LM must be equal to OM minus OL. Agree? OM is this total length. Subtract this much portion OL, I'll get LM length. What is OM length now? X2 minus OL length X1. Is that AC length clear to all? Bhumika, Milan, Alifia.
Yes, sir.
Yes,
Good,
sir.
Arnav is back.
It's clear.
Now I need BC length. Look at the diagram again. I'm writing BC length as BM minus CM. What is BM height? Y2 minus CM height Y1 because CM is same as AL.
Yes, sir.
CM and AL are same. Now exactly if you recollect, these are the two things that we wrote in this slide. AC is parallel to x-axis. Distance between the 2 points is difference of x coordinates. BC is parallel to y-axis. Distance between them is difference of y coordinates. But neither AC nor BC is going to be the length AB because AB is not parallel to x-axis or y-axis. Now what does theorem say in triangle ABC? Can I write hypotenuse AB square should be equal to AC square plus C square. Agree? What is AC? X2 minus X1 whole square plus BC square Y2 minus Y1 whole square is AB square. What is my length AB? Finally, under of minus X1 whole square plus Y2 minus Y1 whole square under root. If you look at the first bracket, it is a line parallel to x-axis. Second bracket is a line parallel to y-axis. If the line is neither parallel to x-axis nor parallel to y-axis, what I am supposed to do? Just square both of them as if they are parallel, square them, add them and take square root. That is the formula. Now before you copy, every one of you, I know this is a new formula to you all. First confirm that the derivation is clear. Look at the board, diagram is on the screen. Small derivation. If that two parts AC length and BC length are clear, then Pythagoras theorem. If both are clear, derivation will be clear. Is that clear to all? Alifia?
Yes, it's clear.
Arnav?
Yes, sir.
Sahas and Milan? Sahas gone. Bhumika? Bhumika, if you are talking, then I cannot hear you. You can type. Yeah, please copy the derivation. Begin the derivation like this. Let A x1 y1 and B x2 y2 be 2 points. Then the rest is on the board. Alicia completed?
Yeah, I've completed. I've completed
Right,
it.
good. Good. So I'm leaving 3 important formulas to you till the next class. We'll make half of next class purely problem solving session. Here you over. I know I exhausted like distance between line parallel to x-axis, line parallel to y-axis, then image with respect to x-axis. There are 3 images we did today. Image with respect to x-axis, image with respect to y-axis, then third is image at origin. We didn't solve much of problems on image, though we did one example just to support the example, and we did one case. Then we came down to distance between 2 points. That also we derived into 3 cases. One case is parallel to y-axis, one case is parallel to x-axis, neither parallel to x-axis nor y-axis, which is on the screen now. These 6 cases, thoroughly revise yourself. Take half session in the next class. We will try to solve problems on distance between 2 points and images. Then we will continue to next another. Is that clear to all?
Yes, sir.
We'll continue the next class. See you. Bye.
Thank you, sir.
Thank you. Arnav is already exhausted. Yeah, Alifia, thank you. See you in the next class.